Now, there are different types of step functions, but for our first example, we're going to look at the greatest integer function. So when you see the greatest integer function, it almost looks like a double set of brackets. You'll see straight bars inside of double brackets, and that means you were to find the greatest integer. What this really is, it's also called a round down function, because when we find the greatest integer, we always round down to the next integer below. So we're never going to round these functions up like we normally do. Every function is going to be rounded down. Now, if you notice what you get when you graph the greatest integer function, you get what appears to be a set of steps. Most of the time, those steps are going to land on integers. There's going to be a few times that it doesn't, but most of the time they're going to land on integers. So when you're looking at the domain and the range is going to be skipping spaces. You see all this empty space here. That's going to be a break in the range. The domain's not going to have a break in the normal function. You can see that every x is going to be accounted for. But for our range, so our domain is going to be all reals, but our range is going to be just integers since it is the greatest integer function. So it's going to be all integer values. So integers are all those whole numbers and their negative values as well. So our domain is all reals and our range is going to be all integers. So let's look at how we come about graphing this greatest integer function. So if I look at the basic greatest integer function, which is f of x is equal to the greatest integer of x. Now I'm going to show you plugging in a lot of values at first, but once you get the hang of it, you won't need to graph as many. So I'm going to input a value for x, and then we're going to have to round that value down using that greatest integer. So I want you to see what's actually happening. I'm going to pick a lot of decimal values. So I'm going to start with 0. Then I'm going to pick 0.1, 0.5, 0.9, 1, 1.1, 1.5, 1.9, and 2. Now eventually you won't need to pick all of these values. I just want you to get a feel for what's happening here. So with the greatest integer function, what we do, like I said, is we're always going to round down to the next integer. So when you're already on an integer, nothing's going to change. So 0 is an integer, we stay 0. But 0.1 is not. So we're going to round 0.1 down to the integer before. 0.5 goes down to the integer before. 0.9 goes down to the integer before. And you see that 1 is a new integer. So here's where we're going to step. All right, now we're going to stay there. 1.1 is going to round down. 1.5 rounds down. 1.9 rounds down. And 2 becomes our next step. So you can see here that we're stepping up on the integers. So how does this look when we graph? So if I start at 0, 0, what happens here is that I'm going to stay at 0 until I hit my first step at 1. So I'm going to stay here, but when I get to x is equal to 1, I'm going to put an open circle there so that it remains a function, and I'm going to step up to the next integer. So I'm actually plotting 1, 1. And I'm going to stay there until I get to 2, 2. And I'll stay there until I get to 3, 3. So it looks like that linear equation, except you're not going to connect the points this way. The points are going to stay solid and constant on those integer values. Now I can just continue this pattern left to right, starting with a solid dot and ending in a circle, open circle, so that it continues that function idea. So now when I'm looking at the domain, You can see that I can include all values of the real number system, and it doesn't matter what they are. But my range is always going to be an integer, 0, then 1, then 2, then 3. So my range is going to be all integer values. All right, now that's the most basic round down function. Now we're going to look at ones that will have things added and subtracted and multiplied and divided to it. So our first function that's not the parent function, that greatest integer of x, is going to be the greatest integer of x plus 3. Now I'm going to perform operations like the order of operations, understanding that these greatest integer functions will act like parentheses. If things are done on the outside and things are done on the inside, I'm going to follow those order of operations. So for this function, I'm going to plug in values for x, and I'm going to pick numbers similar like I did the last time until you get used to these functions. Then I'm going to go inside first. We're going to add to each value of x 3, and then when we're done, we're going to round that number down. All right, so I'm going to start, like I said, like I did the last time. I'm going to omit the 0.1. Just make it a little bit easier. All right, I can even do a 2.5 and a 3 just to see what's happening here. So what I'm going to do first is I'm going to take all of my independent x values and add 3 to them. So that's going to give me a 0 plus 3, 3. 0.5 plus 3 is 3.5. Then 3.9. Then 1 plus 3 is 4. Then 4.5. Then 4.9. Then 2 plus 3 is 5. 5.5, and 3 plus 3 is 6. So you can see now that my integer is starting at 3 instead of 0 this time because we've added 3 to our x value. All right, now when we go to round down, these are going to be all of my 3's. They're going to round down to 3, round down to 3, and here's where I'm going to make my first step. This is going to be a step because it's different than the y values that come before it. Then these are going to be all rounded down to 4's, 4's. And then we're going to step up to 5. We're going to stay at 5, 5, till we get to 3, and it's going to step up to 6. So what we're concerned with here, I really don't need this middle column at all. What I need is the ordered pair 0, 3. Then it's going to step at 1, 4. Then it's going to step at 2, 5. Then it's going to step at 3, 6. And then it's going to stay constant in between those x values. So what's happening here, instead of starting at 0, 0 like we did the last time, we're going to start at 0, 3. We're going to stay there until I hit 1. At 1, we're going to step up to 4. So I need to have that open circle. And then we're going to jump to 5. And then we can continue this using the same pattern in the negative values. They're still rounding down in both directions. So again, my domain are all real values because I can pick any value for x, but the function is always going to give me integer values. So my range are going to be all integer values. All right, let's look at an example where it shows multiplication. Now this one, it's showing you the multiplication on the outside of the function. So that means we're going to have to round down first, and then we're going to multiply our values by x, or by 2, excuse me. So I'm going to start with my input, then I'm going to round my input down, and then I'm going to multiply the result by 2. All right, so here we go. Let me throw some values in. I can use the same as the last, just so you see the patterns happening. All right, so 0 rounded down, 0.5 rounded down, 0.9 rounded down, 1, you can see I jump to the next step. Then I round 1.5 down to 1, 1.9 down to 1, and I'll jump to my next step of 2. So now I've got all integers in the second column. Now I need to take all of those integers and multiply them by 2. So that's going to be 0 times 2, 1 times 2, and 2 times 4. So you can see that now I'm skipping integers because of the multiplication process. So my first ordered pair is going to start at 0, 0. And then I'm going to jump or do my stepping onto 1, 2. And then I'm going to step again at 2, 4. So 0, 0. 1 is going to jump to 2. 2 is going to jump to 4, and then you're going to stay constant in between. Now, if I continue that pattern, it's going every 2 steps. It's being stretched apart because of that multiplication by 2. So my domain's not going to change. My domain's going to still be all real values, but my range is going to be all values, all integer values that are multiples of 2, or you can say that they're all even values. So all integers that are multiples of 2, or you can say even integers, however you want to word that. All right, so that is a problem of the greatest integer that has multiplication involved. All right, let's look at our last general example before we look at a real life problem. All right, so this one has a lot going on. So we have the greatest integer function in here, but we also have a multiplication inside, and we have a subtraction on the outside. So we have 2 operations happening in addition to the round down function. So I'm going to perform the order of operations. I'm going to do my input, and then I'm going to do the inside first. So I'm going to multiply a half times my input, and then we're going to round down. And last, after I round down, we're going to subtract 1 from each value. So again, I'm going to go ahead and pick those same generic values, 1.5, 1.9, 2, just to see what's happening. So this time, I'm going to multiply each of those by a half first. So 0 times a half is 0. I'm going to have 0.25. 0.9 gives me 0.45. 1 gives me 0.5. 1.5 is going to give me 0.75. 1.9 is going to give me 0.95. And I haven't reached an integer yet, but 2 times 1, or 1/2 times 2 is going to give me 1. Now after I multiplied all those values by 1, or 1/2, I need to round them down to the lowest integer before. So these are all going to go to zeros until I hit 2, and there's my first step. All right, now I'm not done. After I multiply them by 1/2, then I round down. Now I need to subtract 1 from each value. So that's going to give me a -1. -1, -1. We're going to stay there until we hit 2, and 1 minus 1 is going to give me 0. So my first step's going to be at 0, -1. My next step is going to be at 2, 0. So 0, -1, and my next step is going to be at 2, 0. And what happens here is that I'm going to stay at -1 until I hit 2. So you can see that my bars are actually doubling in size, and that's because of that 1/2 on the inside. So in the last function, I had a 2 on the outside and it stretched them vertically. This time I have a 1/2 on the inside and it's stretching it horizontally. So it changes the value depending on where that multiplication is located. All right, so let's talk about the domain. The domain, again, involves all real numbers. But my range, last time it was every even, but it's jumping every one value now. So my range is all integers again. All right, so this one had a lot going on, but basically, at the end of my graph, I should see that my values have moved and they have stretched. So we're going to talk about what that means later on. All right, let's look at our last problem today. It says one psychologist charges for counseling sessions at a rate of $85 per hour or any fraction thereof. Draw a graph that represents this situation. So $85 per hour is going to mean that up to the first hour, you're going to be charged $85. When you go over 1 hour and 1 minute, you're going to go to the next hour's value. So let's look at what this is going to look like. So we have 2 variables. Our first is our hours. Our second is our cost. So our cost is going to depend on what our hours are. So our cost is our dependent variable, or our y. The hours are our independent variable. We're going to represent those by x. Now, at 0 hours, obviously we're not being charged anything for the session. But as soon as we go into 1 second or 1 minute, however you want to find that, as soon as you get over 0 hours, we're going to be charged $85. Now we're going to be charged that all the way until we get to 60 minutes or 1 hour. As soon as we are over 1 hour, so I'm going to start writing this a little differently. As soon as we are greater than 1 hour, but less than or equal to 2 hours, we're going to be charged 85 times 2, or $170. As soon as our hours are greater than 2, but less than or equal to 3, we're going to jump to the next cost, which is going to be $255, and so forth. All right, so if I go back and fix this and write this correctly, this is 0, 0, but as soon as we are over 0 hours, but less than or equal to 1 hour, we are at $85. So our jumps are going to look a little different this time with where I put that solid dot. So I'm going to start at 0, 0, because obviously at 0 we're not going to be charged anything. But as soon as we go over 0, we're going to be at $85. So I'm going to count these by ones. And I'm going to count these. And I'm just going to give myself some room here. So I'm going to count by 85s. And then I have 170. And then I have 255 for now. I'm counting by 85. So this is my hours and this is my cost. So now I'm going to plot this. At 0 hours, it costs me $0. But as soon as I go over 0 hours, I jump up to 85. So I'm going to put my solid dot there, and I'm going to keep it solid until I get to 1 hour. Anything over 1 hour is going to jump to 170. So in this case, the open circle is actually going to go first. And the pattern is going to continue from there. So this is showing you the costs. So if I went to 6 hours, I can jump up on my graph and find what I would have to pay if I had 6 hours worth of counseling sessions. So this was a real life example of how to use a step function. All right, I'm going to leave some problems on Google Classroom for you to try, and I will talk to you tomorrow. I hope you have a great day.